Yes, I'm really gonna take it apart again, the little pink thing. Have to sort out what's the matter with the speaker or the baffle. Maybe the speaker is kaput. We'll have to test, maybe attach it properly, see what the problem really is with this baffle, maybe replace it, just sort it out. So let's go. Okay, it's not the cabinet, it's not the interaction of the speaker with the cabinet, it's inside the speaker. Okay, I ripped out the baffle, and I do think that this baffle is already an aftermarket idea. And maybe the amp originally came with a 6-inch speaker. It's gonna be very, very tight to fit a ceramic speaker like that into the amp and still have it all fit in well and not interfering, but we'll see. Just first try and get this shield or this grill off of the baffle. This is the original speaker, and I had to do some research on that. And the way it is constructed, I can only conclude that this is an Alnico speaker. Fortunately, it's a bit damaged. This is the original ceramic magnet speaker that came in my Harley Benton, a little champ amp, and this is the ceramic magnet Jupiter speaker I recently ordered to replace the one either in the Davoli or in my little champ. And they're both ceramic magnets, but you can see the size of the magnet. Okay, the new baffle is installed. I need to add an additional screw here, but the main problem is, of course, whether the amp part, the chassis, will still fit into the cabinet without touching the speaker. And if it doesn't touch the speaker, is it far enough away from the magnet to avoid interference? So the chassis goes here on the top. So for starters, I already moved the speaker a bit down, but this still wasn't enough. So we will have to get rid of the old filter capacitors. This part is what's causing most of the problem, so we will have to remove that big cap there. So the idea is to mount two tag board brackets here, and there, and to put all the capacitors, all 4 of them, in here, as well as a couple of diodes, 4 of them, to make a new rectifier, because these old selenium things are not really quite reliable and not very efficient. So we'll take some diodes, some like 1N 4007 or something like that, and wire up the capacitors like this. It's very strange that they put like small filtering 32 microfarads in the first 2 stages of filtering, and then they add 50 or 47 microfarad caps. But that's exactly how it was in the schematic. And the weird thing is that these 250 microfarad caps have been switched while they rewired it, and they are now here. And these are now in this position. But in order to avoid things from shorting out, especially here in the power section, I will have to remove the protruding ends of these screws that hold in the power transformer. Getting out the Dremel tool. Okay, after a massive amount of drilling, hacking and what have you, okay, we have 2 holes to mount the terminal strips, and let's move them a bit off the board so that they certainly don't make contact with these. Well, here is a new power section. 222 microfarads in parallel, one beneath the other, just to save some space, because putting them all next to each other wouldn't have worked at all. I tried to do some engineering, which is not my strongest point, to get them packed in here. The AC power will come into this, on this point here, middle of the bridge rectifier.
Full bridge rectifier.
This is grounded. And from this we will get the B plus to the first node, 33 microfarad filter cap, dropping resistor 5K, dropping resistor 10K, this is 9K, and then 22K. So we'll have to get the power in. I had to extend the leads from the power transformer. These will go, blue and red will go to these points as AC power, and then we will get the B plus from there. And I will need to rewire all these high voltage nodes to the proper points in the circuit. We're probably going to be able to feed some. We'll probably be able to feed some leads through this small hole that is still covered by the capacitor on the other side. The AC came here to this selenium rectifier. We're going to remove this, put this signal wire to the floor, remove these big resistors. They are part of the power rail, and we replaced them on the other side. Disconnect that old filter cap, and that will make a difference, because I don't understand why I think they changed this one. There used to be a big filter can right here, so they replaced 2 of the capacitors and they left 2 others in circuit, probably because they didn't have any room left. We'll need to readdress this, put this down on the board to make room for the speaker, which is protruding here. Yeah. Well, here is the filter cap that I suppose was already in a replacement, Uranio. And I was not too keen on replacing it because I thought it was quite new, and it was at least younger than the other filter can. I still had to remove it because the speaker doesn't fit in with this cap in place, and we'll try to redo most of the wiring here to make the amp fit the speaker. But look at this. Uranio. Oh. Completely exploded. It's as dead as a doornail. It doesn't even register the capacitor. Let's try the other one. Dead as well. It doesn't measure at all. Just for reference, here is a brand new tube amp Fokker capacitor, very expensive, very new. Just to verify whether my little device is okay. Well, it's kind of nice. Perfect. Loss is 0.6%. It measures like 53 instead of the 47, but that's completely within tolerance, of course. Strangely enough, the old filter cap, the metal can, measures out very good for something 60 years old, yeah, from 1960. The other side is just the same. So that's the reason why they probably kept that one in place while still changing the other one. But I'm still surprised why it saw so much damage. So here's the other side of the canned cap. 45, which is very good. 2% loss is okay. But it's out of circuit and replaced now. Maybe this is the perfect angle on the power section. This may even still be better. Yep. I don't care if things explode, but I do want to have it on film. If things explode, that would be spectacular. I just connected up the speaker and I'm just gonna turn it on. The power section should be okay, but you never know, huh? I'm gonna check the tubes for filament glow, and if nothing happens and we get no sound at all, then you may have to turn it off again. Okay, we got a pilot light. That's something. We got glow on the tubes. Did we get sound? And maybe I it was working quite okay without the two main filter caps working. They were just being there acting like 14 meg resistors. One was 14 meg, the other one was 5 meg. Okay, I have been playing with the bias and adding this 150 ohm resistor in parallel with the existing 220 ohms brings the resistance down to 85 ohms, and then we get like maximum dissipation levels, like almost 10 watts, 9 watts per tube. I'm not going to lower the resistance that much, but I am going to lower it to 100 ohms or maybe 110 ohms. We'll see. I also did some experiments by just adding an extra capacitor of the same value in parallel. Okay, I installed the mains fuse, which was missing, and that was like really important to sort of measure what the power transformer is sucking out of the wall. I was maybe thinking about changing jack to a shorting type, but